Hi, I'm Adam Philippi, a computer scientist at the National Human Genome Research Institute. I'm one of the scientists that helped finish the first truly complete sequence of a human genome. Now, although I've worked on this problem for years, I'm going to show you today, through the Wonder video, how to do it in just 7 easy steps. Step 1. Find a DNA sample. For our project, we used a special type of cell that can multiply many times and make lots of DNA. But you can use a more simple sample. Blood works fine. Maybe you want to sequence yourself. Step 2. Isolate the cells by centrifugation. That's a scientific word for spinning something around super fast to separate the contents. Step 3. Once you have the cells collected, you can extract the DNA and get it ready for sequencing using some chemicals. You need to do this very carefully so that the DNA doesn't break into pieces. I leave these next few steps to the experts at NIH. When you're done, if it looks like a glob of snot in the test tube, you're on the right track. Step 4. Load the snot or sample into your favorite sequencer. If you're like us and just can't decide, use both. This one may look like some kind of space-age toaster, but this toaster feeds DNA strands through tiny holes called nanopores, and reads the individual nucleotides as they pass through the pores using some fancy electronics. This one may look like a refrigerator, but uses lasers and cameras to make a movie of the DNA being copied. Pew, pew. Now we wait for all the data to be generated. While you are waiting, you can admire the colorful display that shows which of the nanopores are actively sequencing. Amazingly, you can watch the sequencing happen in real time. This step can take a few days. Step 6. Once you have collected all the data, it's time to build the genome. Unfortunately, we haven't figured out how to sequence a whole chromosome in one piece yet. And instead, we're left with millions of smaller fragments. It's like putting together a million-piece puzzle. Luckily, some impatient computer scientists have written computer programs called genome assemblers that can automatically stitch everything back together again. Step 7. Analyze the assembled DNA sequencing data for quality, making sure there are no problems. It is good to bring in experts for this step. They will use computational tools to search through the data like genome detectives looking for clues, and fix any gaps or errors they find. This may sometimes look like pushing noodles around on a screen, and you may love eating noodles, but try and stay focused. You're almost at the finish line. That's it! With those last few fixes, the genome is finished. Briefly bask in the glory of knowing you sequenced a complete human genome. If you have the informed consent of the donor, you can now upload it to a genome database and share with other scientists. Now, do it all over again and again and again. With a diverse database of human genomes to compare against, doctors will be able to better diagnose and treat diseases, and all of us will gain a better understanding of the wonderfully big extended family we call humanity.
Why would you just go out your blood? That was great.